Hey everyone, it's Jim
And Charles
from Valves and More, an online vintage tube store. And today in Tube Lab number 228, we're going to talk about power supplies and rectifiers. In fact, we were going to talk about power supplies and rectifiers last Friday, and then we got slammed. The new kit amp store, Melotone Amps, got so many orders in over that weekend that we worked the full weekend. I worked evening shifts.
Yep. We had no time to even shoot the video or anything.
Yeah. So, anyways, we got the shipment out. I think the carrier had to put on an extra large truck. We had so many boxes going out. But anyways, it was good to get that many kits heading out. And who knew so many people wanted a great sounding phono preamp? But when I started designing prototype phono preamps, I did it initially. I did one for myself years ago because I was just disgusted with how bad commercial preamps sound. And now we're on essentially Mark II, the modern line version. So yeah, it's exciting times.
And we can't wait to hear some feedback from the test builders and the other builders out there. It's going to be great.
Yeah, but first caution everyone: electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. Well, we started laying out this episode around rectifiers, what they are and how they work. But it didn't take long to realize that you can't understand rectifiers without understanding the entire power supply. So today we're going to start at the very beginning and work our way forward. Okay, let's just get started. So we're not going to spend too long with schematics. I know they're boring and and they put everybody to sleep. So we're actually going to haul out some real big iron in a minute.
Yeah, we got some nice stuff here.
So everything starts at the plug. And years ago, household voltages and transformer builds were a real problem because there weren't a lot of universal transformers, so manufacturers would build transformers for the lower voltage region and transformers for the higher voltage region. Nowadays, trade and manufacturing is so integral in essentially the world that most transformers are universal types. Not all, but many of them are. So you just simply have to wire a transformer a little bit differently depending on what voltage region you're in. So this is the wall side or primary side of a transformer. And this takes whatever voltage you've got at the wall plug and transforms it. So you have windings on the primary side. That's why the depiction of a transformer shows what looks like wire wraps or
sort of wire coils.
Wire coils, which is what we're really looking at. And then we see what looks like sort of an iron core, which is exactly what a transformer is. And then we see the same thing, more wire coils on what is the secondary side. So we have AC voltage, either 50 hertz, which is 50 cycles a second, so alternating current at 50 cycles a second, or alternating current at 60 hertz, 60 cycles a second. And what that means is that the AC signal or power curve cycles back and forth, so it alternates 50 times a second or 60 times a second. And that helps easily push electricity long distances. That's the primary difference between DC and AC. And we're going to be talking about DC in just a moment. So DC can go distance, but it has a requirement for really large wires to avoid line loss. And it's just not practical. So
back before AC became mainstream, there was essentially a power plant on every block to allow for efficient transmission.
Yeah, I think the first AC wiring of a city was in New York, and of course, they had to run really large gauge wires and
have a lot of plants distributed around.
So if you want to read an interesting electrical story, read about the introduction of household electricity. It's really quite fascinating. So what happens? How come we have our household mains on this side and we still have AC voltage on the secondary side? What's going on here? Well, what happens is the transformer has a core that gets magnetized by the primary windings, and that induces a voltage on the other side. So this is an electromagnetic device.
And even though each side is isolated from each other, a voltage induced on one side will appear on the other.
Yeah, and there is some benefit to having this isolation. Now, if you have a really noisy supply, does that carry across? Quite a bit of it does. But this magnetizing of the core must have some smoothing out of the AC voltage. Now, why couldn't we just, if we've got, let's say we've got a requirement for 120 volts on the secondary, why can't we just wire directly from the plug over here? And in fact, years ago, there were some instances of equipment built that way.
A lot of very inexpensive TVs.
Yeah. And then we saw some catastrophic failures, electrocutions, and then manufacturers realized that the cost savings just weren't worth the insurance and liability.
And even if you need 120 volts anyway, it was always a good idea to have an isolation transformer in there.
Yeah. Now, the fun thing about this whole thing that we're discussing is that way back when I was a young audiophile, Bob Carver of Carver Amp fame came out with a line of power amplifiers in which he said that you're essentially plugging my amplifier, the output of my amplifier, into your wall outlet. And it's as close as I can get to essentially your amplifier is the power plant, the nuclear power plant or the coal-fired or gas-fired.
There's as little between that and the power source as possible.
So those ideas about plugging directly into the outlet have made their way all the way into audiophile design work. Now, the reason why we're talking about all of this and why it's so important is that you have to think about a valve amplifier or even a solid-state amplifier or a preamplifier basically being a very complex, depending on what the circuit is, a fairly complex series of valves that basically regulate the power from your wall outlet. So everything from here to your speakers is essentially regulating what is available here. And of course this here comes from the transformer on your street, which comes of course from your power plant. Okay, let's move forward. So we're actually working on we were talking about it earlier, we're working on the new modern line phono preamp. This is the power supply schematic. So here's a solid state full array or full bridge diode, so 4 diodes. What these are doing, and later on in the next episode when we talk about tube rectifiers, what these are doing is taking that beautiful AC sine wave that we can't use to run a DC circuit, and they're giving us raw DC. And raw DC is basically the positive pulse of the wave, and as a result we end up with a really rough kind of a DC. So it's no longer an alternating current, but it's no longer a very clean looking DC. And everything after that in a power supply basically is filtering that and smoothing it out so that the DC signal is perfectly flat and without noise And in this case, you'll see we have a dropping resistor here that's setting a final voltage. But the power supply for the phono preamp is basically trying to give us as clean, high voltage DC as possible at the voltages that we need. Now, to really blow your mind, I'm going to drop in really quickly, and we're going to look at a different power supply. This is the power supply that's going to be used for our new OTL headphone amp. And it is quite similar in the primary and secondary side, though it's using a different transformer. It's using a toroidal transformer, and we'll look at transformer types in just a minute. It's got that full bridge array, so a solid state rectification, but look at the filter stage here. It's got capacitors, resistors, capacitors, resistor, capacitor, resistor. What is going on with that? Well, each and every one of these is a filter stage. And because headphone amps, particularly OTL headphone amps, which have an extraordinary amount of clarity and depth, they require, and of course, when you put your speakers literally on top of your ears, if there's any noise in the amplification stages at all, you're going to hear them. And if you hear noise, that means you're not hearing some low-level music. Mm-hmm. Now everybody gets why a low-noise, well-designed power supply is so critical. But it's even more important than that. These capacitors are large, 390 microfarad. That's a big capacitor. If you were to short that up on the tail of an elephant, he'd probably sit down right away.
Or fall down.
Or fall down. And if you're really unlucky, he'd fall down on you. So, and if a human shorted that out across their heart, they may well just drop dead. So that's how much power is in one of these little capacitors. In fact, I've got one here.
You always have to be careful around big caps, and especially with a filter network like this. So these are called CR, capacitor resistor filter networks, and they're very common in power supplies. We actually have some in the phono design as well, but we're also using an LC, which is a choke capacitor network here too.
Yeah, and we're not going to get into the ins and outs of those. What we're trying to do is to get you oriented as to what this rectification is doing and what the heck this is and what it looks like in real life. So I think it's time to start pulling out the iron, Charles.
Yeah.
Okay, this is a Hammond transformer. I think maybe it's what we use for the GU50 monoblocks, but maybe it was for the prototype headphone amp. But anyways.
Yeah, I think we actually use the 370EX, so it's a very similar model.
All transformers, at least when they're brand new, will have a label telling you what the heck the windings are, and there'll be a spec sheet or data sheet that has a good, clear description.
And Hammond's really good for that.
Yeah, they're very good for it. It doesn't look like it's very big or heavy, but this is a heavy transformer. In fact, if we were to put this into a kit, into an amp design, we probably would put handles on the design just so that you could lift, because this is, of course, only part of the weight. Now, this type of transformer is called an EI, and you can see a little bit why it's called that. You see here, there's a little sort of a crease or a gap, and there's another one over here, and what those are, and you can see the essentially the layers. What they are is pieces of E-shaped and I-shaped plates that are assembled around the windings themselves. Remember we were talking earlier about how the primary and secondary windings make up a transformer, and of course how many windings you have and how big that wire is and how large the physical transformer is will determine the voltages and the current capability. And you're going to see the spec on all these transformers. They're going to tell you what the voltage is and what the wires are and what the current capability is. So this is a big one, and this is essentially an old-fashioned type, but they're still very commonly used. They still have applications today. We still use them in kits for the simple reason that they have a good application in particularly in power amps, because the other types we're going to show you are problematic once you get into bigger current, bigger power handling transformers. Okay, what do you got next, Charles? Okay, so here are two transformers that are probably, almost certainly EI types, just like the one we looked at, but they are mil-spec and they are potted. And what potting does is it takes the
whole assembly we were just looking at, basically.
Puts it into some kind of a case. If it's a fancy amplifier, it puts it into a pretty looking, housing. And then they actually will fill the gap with some kind of a material. So it could be a tar-like material. It
could be a resin.
It could be epoxy. And the idea, of course, is that the entire thing is now encased. It's much more durable. In fact, I have a whole bunch of these. These are aux transformers for filament supply. And I think all the ones I have were made by Western Electric, believe it or not. And we actually use one of these on our bench to set filament voltages for our tube tester. So, yeah, and you can see all transformers will have, you can see here they even show the windings. They tell us what the taps are, what the voltages are, what their current capability are. And it's easy to see in this case, there's the primary or wall side. And you can see here they even marked 50 to 60.
But
cycles.
Given that this is a very old transformer, this only has one primary, so it's not universal. This is actually really neat. It came out of a power supply that was used to run a high voltage power supply, bench supply, that was meant for testing nuclear carbon rods.
Yeah, and you salvaged it?
Yeah. Yeah, well, I couldn't leave this behind.
Did you bring the Geiger counter over first before you took it apart?
Click, 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 click.
Okay, what's next? What about audiophile transformers and modern types? Well, the toroidal comes to mind right away. And even though it's got an isolated wrapping around it, you can actually see the windings. And they wrap all the way around an iron core. In most cases, transformers wrap around an iron core, though there are hybrid type cores out there. And what are the advantages of a toroidal? Well, if you can get one that fits in your chassis and is reasonably priced, these are fairly expensive transformers, you can use it. So in the case of the new OTL kit headphone amp, we were able to find a toroidal that was reasonably priced that worked quite well. But there are other advantages, eh, Charles?
Yeah, they tend to be more efficient with the power conversion. They're lighter weight. They require a smaller iron core, and
the biggest advantage of all, of course, is their lower noise.
Yeah,
because if you think back to the EI type or the standard transformer type that's very, very common. Remember those leaves of metal that form it? Well, they can start to vibrate at certain frequencies. And in fact, you will hear a hum. So if your mains supply is 50 hertz or 60 hertz, those things will start humming along.
Mm-hmm. And if it's an older transformer, or maybe those plates have delaminated a little bit, they get louder very quickly.
Yeah.
That's not an issue with these guys.
Yeah. The big problem with these, besides the fact that they're more expensive to make, is that as they get larger in size, particularly for voltage and for current, they start to get extremely big and very, very expensive. So for the headphone amp, even though it's a really powerful headphone amp, it's still relatively small voltage-wise and current-wise.
Yeah.
So a Toroidal is a great choice for that.
Yeah, you also have to be careful with them too because they have a higher inrush current than all the other types that are out there, so you have to size your first capacitor accordingly.
Okay. Well, what about hybrid? Something in between a Toroidal and an EI type, Charles?
I think we've got something for that.
Okay. Well, a hybrid transformer is an R-core. And you can see they are really different looking. So it's not hard to see where the iron core is. And you can see that there's some ceramic insulators. This is actually a junk one that we pulled that we used years ago for our classic line kits.
Let me just see if I can show you the windings in there, if you can see that.
Yeah, it's quite an interesting assembly.
There's a winding around here and a winding around here. Let me see. You can probably see it from that angle. See that?
Yeah. Isn't that neat? And of course, this is a much bigger version. So like a Toroidal, an R-core suffers the same problem. As the voltage and current requirements increase, they get large really quickly. And this is heavy, like really heavy. And it's not a particularly powerful transformer. So for smaller circuits, like our kit preamps, these R-cores are absolutely wonderful because we get the advantage of the Toroidal, low noise. We get the efficiency of the compact design, and they are fairly reasonably priced as well. Now, again, they have to go into a housing, or they should, in my opinion. And the housing on a transformer is not just to make them look pretty. It is, of course, to shield, because the magnetic field that makes these things work doesn't restrict itself just to this general region here. It expands off. And if you were to draw the field, it would be really quite extraordinary to see those magnetic waves coming off of it. And of course that will make for noise in the circuit or anything adjacent to it. So by putting a metal housing over it, you're basically sticking it inside
a shield.
A shield.
You're isolating it from everything else.
Yeah. So
these kind of combine the best of both worlds, but they're better suited for lower power applications, and that's why we use them in all of our preamps.
Yeah. So that should be, I think, a good starting point for next week, in which Charles has actually building a bench display circuit for a tube rectifier.
It's something I've been wanting to do for a while, to show you different setups and how you can configure it, and we're looking forward to it.
Yeah, and we're going to try and get scope channels on there and voltmeters, as many things as we can fit onto a small screen to show you the actual rectifier circuit in operation. And the rectification, so in a power supply, you've got to have you've got to start at the wall outlet, and actually this is, I think, a hospital grade outlet. You can see it's got a little green mark on it. So this is a big heavy duty outlet, and it's what we use in the shop. You gotta have a main supply. You have to have some kind of a transformer. You have to have some kind of rectification, and you have to have some kind of smoothing. And next week we're going to look at that rectification, and hopefully we can take away some of the mystery of how rectifiers work in circuit.
Yeah, well, especially tube rectifiers, they aren't obvious with how they work. It's pretty interesting.
Yeah. Now we haven't been online for 2 weeks, and I think you have a lot of things that came in, Charles.
Oh, we got some great stuff in. Let's go take a look. Wow, that is a lot of EL84s. We've been getting in a bunch of great ones from Sylvania and from Philips.
Yeah, we had quite a good inventory in stock, but not that many match quads. And then we were lucky enough to find a bunch of new old stock Sylvanias, and we were able to make up some quads.
A decent number of them, actually. So let's go through them. We actually have 3 different types of Sylvanias here, and one that we didn't even know existed until we actually had it come in.
Why don't you start with the Phillips, the Mullard Phillips version?
All right. So here's the Mullard made, Phillips branded, EL84. These were made in the Blackburn plant in the UK.
And the reason they're considered to be the best version ever made was, of course, Mullard Phillips invented the type. In fact, they invented the EL84 as a miniature version of their very successful EL34. And these are getting very rare, and they're almost extinct. And we have, I think, 1 new old stock quad left.
We have 1 quad of them, and they're excellent testing. They're bang on spec, exactly where they should be, and somebody's going to be very happy with these tubes.
What about the Sylvanias? I mean, if you can't afford a Mullard EL84, the Sylvania is a good option. Sylvania made some awesome tubes, and the EL84 version that they made is no different, but they made a number of types.
Yeah, so we have what's commonly called the black plate version, the gray plate version, and this guy over here is a black plate version, but there's a small difference to it, and I suspect that it's a higher spec one. So if we go over here, here's the standard black plate. You can see it has these beautiful shiny black plates on the inside. Well, not plates, plate. And
the black that you're seeing is the coating.
Yeah.
And of course, the coating has a lot to do with the electrical performance of the tube.
And speaking of that, take a look at how this is testing here. A new old stock center value is 37 milliamps for us at our testing point, and these are testing well above that. They have lots of life. They'll push a lot of current. So that's really nice to see. It's usually a good sign whenever a tube is testing above spec like that. Then we have the same tube, but with a gray plate. So it's a different cathode coating on there. And these tend to be less common. You do see both versions.
Yeah, now a lot of manufacturers had black coatings for, well over half a century, from the time that tubes were invented almost through the early days of radio and telegraphy, up until about the Second World War, and then shortly after it, manufacturers started working, I think, hard to update their coating formulas, and almost everybody started in the 60s started switching over to gray. And
even tubes that you normally see with the black plate on them, especially from Sylvania, you'll occasionally see gray plate versions of them, although they are quite rare. So yeah, so we have that. And these guys over here. So these are actually quite interesting. These are Baldwin branded.
So Baldwin was an organ manufacturer.
And most of them that we had come in are marked with these red tops on them.
And that almost always indicates a select tube.
They're also testing nice and tight, which is great. And the big difference between these guys and the other black plates is that we have this top filament shield up here. Now let me see if I can get that in focus here for you.
And that's usually up there to lower noise.
And so these are also testing very tight, very good, right where they should be. And you'll notice that, or maybe you haven't noticed, but each one of these Sylvania types, they all have the same tube code on them. So we don't have a separate listing for each one. They're all under the same listing. If you're interested in one version or the other, just send us a message with your order. Let us know what you're interested in. Preferably actually send us a note before you order and ask us if we actually have your type still in stock, because we don't have a lot of specifically these two guys right here.
I don't think there's a huge difference in performance between all of these tubes, but people have their preferences. For a long time, people have preferred black plate tubes. Doesn't matter whether it's a preamp tube or a power tube. If there's a black and gray plate version, and there often are, they'll prefer the black plate version. And I'm not sure if there's any foundation for that preference. I think just black looks better.
It could just be that black typically meant that it was an older tube in a lot of different design cases, so it may have meant that an older tube typically would have sounded warmer, but who knows?
Yeah. And I think there could be some justification for saying that because, in general, as a very, very general rule, the older the tube, generally the better it sounds. But interestingly enough, as we move into the post-World War II era, manufacturers became more and more automated. So tubes became much more close in their manufacturing tolerances. So as you move into the gray plate era for Sylvania, for GE, you start to see much tighter manufacturing. So I think there's a bit of a give and take for preferring one over the other.
Mm-hmm. All right, we've got some other tubes to take a look at, so let's clear the deck and we'll be right back.
Okay, now we've got something fairly rare. In fact, I would have called these extinct, but we've discovered some live ones. This is the rightly famous Tungsol 6SN7 GTB tall boys with a brown base. We almost never see them with brown bases. Nice big full chrome domes. This is the original vintage Tungsol, so don't mistake these for the modern reproduction slapped on label version.
Yeah, the ones that tried to copy this look with their own brown bases. Not the same tube, not the same manufacturer.
And not the same sound, unfortunately. So these are very, very rare tubes. We've got one matched pair in the store, and these are new old stock. Now, the listing in the store is for a used tube, and times are tough for a lot of people. So and they're very expensive tubes. And if we were to price them new old stock, they'd be even more expensive. So what we've done in the store is we've just increased the listing of the standard 11B, which is for the used version. So we're going to hold the price on these as though they're used tubes. And yeah, so
it's a bit of a discount for somebody that's quick to the store.
Yeah. Okay, what's next? And these are a tough power tube to keep in stock. This is the true vintage Svetlanas, or SEDs, Svetlana Electronic Devices from St. Petersburg, out of production since
roughly 2002, I think, is whenever they ended off.
And this is probably one of the best, reasonably affordable vintage EL34s out there. They sound amazing. They've got a nice, warm, rich mid-range. They're reliable, and
they're pretty cool looking too, to be honest.
Yeah, and caution everyone, there are reproductions, there are fakes, there are reissues of these tubes. None of them are anything like the original tube. A lot of them look really close to the original tube, and if you've been watching this channel, you know we've been pointing out the differences. Charles is the expert on identifying which ones are the fakes and which ones are the real ones.
Look for the different tines here. We got a downward facing one and we've got an upward one that comes back down. And that's a pretty sure bet that you got a real one.
Yeah. So we actually got lucky and we were able to make up a new matched quad, tightly matched too. And I think the center value for the L34 is 63 milliamps.
Oh, somewhere around there. And these are testing really nice.
Yeah. So we're over the new old stock value. So that's always, as Charles says, that's always a very good sign. And we've got, I think, one more power tube quad to look at. And last up is probably the best 6550 ever made. And again, it's a Svetlana tube. Svetlana, I'm not sure what happened, but people seem to have gotten in their minds that Mullards are great. Vintage Mullards, and because there's a lot of fake Mullards out there. In fact, if there was a tube that was faked more than anything else, it would be the Mullards, maybe the Telefunkens.
Yeah, Telefunken is probably just edging it out a little bit, but not by much.
In our experience, though, working with a number of true St. Petersburg Svetlanas for our kits and for putting together sets for our customers, the Svetlana made some of the best vintage tubes, bar none. And the 6550C is just an excellent tube. They will come with some different labels, but this particular quad is testing in around 120 milliamps, and the center value is
I think it was around 90, give or take a few.
93 or 94 milliamps, so they're way over spec. But the thing about power tubes is the plate idle current of a power tube tends to be fairly variable, even from the best manufacturers, which is why power tube matching is so critical. Yes, I know you have an automatic bias setting on your amp, but if you start off with a very mismatched quad and you're hoping that your amp's technology can match it up for you, well, you start off with a great differential, and really those auto biasing circuits or a manual biasing circuit is designed as a trimmer. It's not designed to take a tube that's way low and a tube that's way high. Did I just give everybody 2 fingers? I did. Nothing was meant by that, folks.
You essentially lose a lot of their operating room by trying to bias them up together.
Yeah.
So you really want them as closely matched as you can.
Yeah, and then if your amp has a biasing feature on it, then you're basically trimming it so it's right on the money. Anyways, these have been on sale actually for about a month. We have quads of these in the store, and we have quads plus spare, and the discount is huge, but this is the last week of the sale. So I'm going to pull the sale at the end of the week. So you've got a week if you're really interested in getting into one of the best 6550s ever made. And if you stayed to the very end, here's some discount codes to help you out. And there's a secret cheers code that quite a few people get that's easy to figure out. And we can reach almost everybody around the world with flat rate $20 shipping. And if your order's $150 or more after discount, the shipping's on us, folks. Stay safe, everyone. This is Jim.
And Charles.
Signing off. Cheers, everyone.